Now, the actual dimensions of an A4 piece of paper are 29 by 7 times 21.
Is that legit?
Which is legit, right? That's pretty terrible, okay? So what I'm going to do is assume an A4 piece of paper is 30 by 20. Now, as you will discover shortly, that doesn't actually make things much better anyway, but it'll make it slightly quicker for the algebra. Okay, yeah, it looks better. Okay. So our question is, remember the idea is that you cut out corners, okay, that are squares, and then we're going to fold it up and make a box. Okay. So my question is, what's the dimensions and volume of the biggest box?
Biggest in what way?
Biggest by volume. Biggest by volume. Okay. Now, again, this is a great example of the fact that it's a simple setup, right? There's very little. So we need to actually put pen to paper and try and add in some complexity so we can actually start to solve it. Okay. So the first thing you should do is draw yourself an A4 piece of paper. Okay. Now, remember, the idea is that squares get cut out of the corners. All right. So you're going to get this kind of situation. Okay. Now think back to the previous question. Remember, the idea is that you've got some quantity that you want to, well, last time was minimizing. This time we want to maximize, right? What's the quantity? Volume. Right? So I want some expression for volume, right? And I also want it in terms of one variable. Okay. Now you look at this. There's actually a variety of different things that you could choose as your variable. Okay. So for instance, you could choose this length here. Okay. You could call that x. Right? Now, if this is 20 by 30, okay, that would make the dimensions of the squares, let's see. You've got x here, and that's 20 across. So it'll be 20 minus x, and there's two of them. Right? Now, because that's a square there, you've got another one there. So this would be, what would that be? 30 minus 20 minus x. 30 minus 20 minus x. Right, so would that be 10 plus x? Yeah, of course, because that's 30, that's 20, right? So you can do it like this, and your volume of this box that you get when you fold it up would be, let's think, x by 10 plus x by 20 minus x on 2, okay? So then you would differentiate that, okay? Now this will give us the answer just fine. I'm not actually sure if this is the simplest way to do it. I'll show you the way that I did it in my head. Instead of calling that x, you can pick anything you like, right? So I'm going to call this thing x, okay? Just because, I don't know, that was the first thing that came to my mind, okay? So if that little square out there is x by x, okay? That makes this distance, that's the short side.
20 minus 2x.
Good. Okay, and this one here.
30 minus 2x.
Okay, so you can see why I went for it. It seems a little better. In that, so I'm going to get rid of this because that's a totally different x, yeah? My volume here will be x by 20 minus 2x by 20 minus 30. Sorry. Flip my numbers around. Okay, so far so good. Now do you remember, where did I go from here? I got my quantity in terms of one variable, and then what was my next step? I wanted to differentiate, right? Now I could differentiate that. It's a product, so I could use product rule, but why bother, right? I think it's probably better just to expand it out, okay? So I actually, just to save you a bit of time, I think I've already got my numbers for this. So
4x cubed. So is it necessary to write domain for the sides?
Yes. Now, before I differentiate and get into finding stationary points, turning points, all that kind of thing, right? Domain is so important to notice because people always forget it and then they go and do working without noticing the domain actually has implications for which answers work and which ones don't. So what is our domain?
X is less than 10.
So
Well, x is less than 20 over 2. Greater than 0.
that was helpful. Okay, so x here, right? I've got a restriction here, right, which is that x can't go further than halfway, so x has to be less than 15. But this smaller side is it's gonna reach its limits first, right? So x has got to be less than 10. Now, could it be equal to 10?
Then you just have one rectangle.
Yeah, that's right. You get the middle. You get like this thing.
The
Greatest box of all time.
You have a box
Now,
like
for
that.
what it's worth, where I saw this question, they actually did say, yeah, you can totally have it as 10, and then you get a box with volume 0, right?
That's ridiculous.
I think that's silly. So
I have a box
Can't
with
even
volume
make
0.
a
You can put
box.
0.
I'm figuring the question implies you must have a box by the time you're finished, okay? So there's one side of the restriction, there's another side, right? What's the other side of the restriction?
It's bigger than less than 0.
I have to make bigger than less than 0.
Yeah.
I have to make some cut of some kind, right? Because if I don't, it's stuck as a rectangle, and I can make like a taco out of it, but anyway, I wouldn't make a box. So there's my restrictions.
Mexican food.
We'll come back to this in a minute.